So now we're going to talk about domain. Again, domain, keep in mind, domain deals with three main functions. That's really the exception. Domain normally is all real numbers unless you see a radical, a fraction, or a log. Logs don't show up in this semester. They're really in the next semester. So for now, if I see a fraction, what I'm trying to avoid, I'm trying to avoid a zero in the denominator. So find the domain of the function. You really don't pay attention to the numerator in any way. You just care about the denominator. You say, well, let's see, where does x squared plus 5x plus 4 equal 0? That's when x equal negative 4 or negative 1. So you would say domain, pick any x you like, stay away from a negative 4 or a negative 1. And that would be my answer. Straightforward as far as fractions. If I see a radical, an even index radical I should say, well, the same deal. I take the quantity underneath the radical, and I would say take that and make sure that it's always bigger than or equal to 0. Because you can't take the square root of a negative number, not for real numbers. Well, subtract 2 from both sides, and there it is. Normally, if I have an inequality, normally I would write my domain in interval notation. A quick sketch will do the trick. Negative 2 included. You don't have to sketch, of course, but you would say negative 2 to infinity will do. And that would be my domain. If I happen to see a radical and a fraction, then I gotta be a bit cautious. Well, here I see the radical, it's right there. It is an even index, but it's in the denominator, so it's kind of the same idea. I'll take the radicand, the quantity underneath the radical, and instead of saying it's bigger than or equal to 0, since it's in the denominator, I will avoid the equal 0, and that does the trick. If I subtract 2 from both sides, and that's almost identical to what we just did right there, except I wouldn't include the negative 2. So fairly simple up till now. And if I have a combination of both, anytime I have a multiple domains within the same problem, I would use a graph. So this we already did. We already know for this, we want x to be greater than or equal to negative 2. So on a number line, what we're saying take negative 2 included, and for this one we already did. We know that x cannot be a negative 4 or a negative 1. So when I say a domain and there are multiple restrictions, I want the domain to satisfy all of them. How would you say that? Well, we would say, look, go from negative 2 to negative 1, don't include it, and then from negative 1 to infinity. So anytime I have multiple restrictions on the domain, a sketch will do the trick. Here, if I look at this, well, I see two things. Well, let's see. The first function, the quantity underneath that radical must be bigger than or equal to 0, so t must be bigger than or equal to negative 1. On a number line, again, I could see that. I want t to be bigger than or equal to negative 1. And as for this radical, I want 5 minus t to be bigger than or equal to 0. So I want t to be less than or equal to 5. There's 5. I want t to be less than or equal to 5. So which region satisfy both of these cases? That's my domain. Domain is negative 1 included to 5. Those are the values that would satisfy both of these radicals at the same time. And if I look at this, this is a bit tricky. I would say I want 4 minus x squared to be bigger than or equal to 0. Be careful, this is not linear. The best way to do this is to use a sketch. We're going to elaborate on that when we get to circles, which is in a few minutes. 4 minus x squared is a parabola that's shifted 4 units up, upside down. When you say you want it to be bigger than or equal to 0, you're saying x has to be between negative 2 and 2. Again, I'll elaborate on that again once we look at the graphs of circles, and that's coming up soon. Absolute value is not going to leave you alone. That's something that's going to keep on coming back over and over. An absolute value is always positive or 0, the absolute value of a. If this a is bigger than or equal to 0, I don't need the absolute value. If this a is negative, I put a minus in front, and that's that. And keep in mind the principal radical, the nth root of a, if n is even, then that's always positive or 0, same definition. So to elaborate on that, what you learned in algebra, maybe this was skipped. Square root of 16. This is asking what number do you multiply by itself to get 16? I'm doing a power. Well, the answer is positive 4 or negative 4. Because positive 4 times positive 4 is 16, and negative 4 times negative 4 is 16. Except this is a square root. It's always positive. Even though negative 4 times negative 4 is positive 16, we're eliminating the negative option because this is a principal radical. A principal radical is always positive. If I look at b, the square root of x to the fourth. So what do you multiply by itself to get x to the fourth? That's really x squared. Done. No need to do any work because x squared is always positive. So that's satisfying this case. If I look at part C, what do you multiply by itself to get x squared? X. Well, that's a problem. You can't just say an x. Why is that? Because if you square a quantity, it's always positive or 0. But if you say x, if x is a negative 5, then this is saying negative 5 squared, which is 25, is negative 5. Since there is a chance for this to be a negative, to ensure that it is always positive, we use an absolute value. That wasn't needed here because this is always positive. And that wasn't needed here because this is a constant, this is a variable, this varies. What if I wanted to know what this is? Well, we go to the definition. If the inside is positive, I don't need the absolute value. And if the inside is negative, I'll put a minus in front of whatever was inside the absolute value. So that's pretty much saying this is x minus 3 if x is bigger than or equal to 3, and it's negative x plus 3 if x is less than 3. And you could pick a value and you're guaranteed that this will always be positive. If you pick x equals 7, 7 is bigger than 3. You put it right there. 7 minus 3 is 4. If you pick negative 7, negative 7 is less than 3. Minus a negative 7 is positive 7. Plus 3 is 10. It's always positive. And something that's going to come up in calculus is the combination of those. You're going to say, and you're going to be careful, if the inside is positive, I don't need the absolute value. What that means, the top doesn't have an absolute value. The top is x minus 3 no matter what x is. The denominator, if the inside of that absolute value is positive, then I don't need the absolute value. And if the inside of that absolute value is negative, then the top is x minus 3 regardless. The denominator will be negative x minus 3. And you'll notice That will be a 1 if x is bigger than 3, and that will be a negative 1 if x is less than. The reason we didn't include the 3 because this happened to be in the denominator. I'm going to shift that up a bit. Oh, that's not going to allow me to do that. Never mind. So the part that probably we overlooked in algebra for various reasons. If I want to solve this equation, I know you're so comfortable with, x squared equals 16. And that's fine. You could do that anytime you want. I want to elaborate because absolute value is not going to leave you alone. And until you really get this definition down and understand what it means, you're going to have a hard time with this. If I want to get rid of an x squared, I would square root both sides. X cubed, I would cube root both sides. The right side is a positive 4. It's right there. It's not plus or minus. The left side is x, almost. It's an absolute value of x. And if absolute value of x equals 4, then what does that mean? That means either x equals 4 or x equals negative 4. So the plus or minus comes from the left side, not the right side. Now, how do you graph absolute value? It's fairly simple. You ignore the absolute value. So y equal absolute value of x. You look at y equal x. When you put an absolute value, that's saying the graph is positive. Here, let me do that right here. Y equal x, a line cutting this at 45 degrees. When you put an absolute value, y equal absolute value, we said this is always positive. So you look at the y. Where's the y below the x-axis? You would reflect that above the x-axis and get rid of that. And that's the absolute value. Of course, you could memorize it looks like a V shape. Again, we're after the process here, not just the answer. We need you to be able to sketch a graph of anything. And I'm touching on all the topics that most likely you've forgotten or it's been a while, maybe you remember. Y equal x cubed, well, I know how that works. That looks like a parabola and minus that. When you put an absolute value, now you want y to always be positive. When you take that part and you reflect it, and it looks like a parabola, except it's steeper. How about this graph? Well, you look at the graph of x squared minus 9. That's a parabola shifted 1, 2, 3, all the way to 9. Let's say that's negative 9. It's a graph that looks like this. It crosses at 3 and negative 3. This is y equal x squared minus 9. When I slap an absolute value, now I want y to be positive. I'm going to take this part that's negative and I'm going to reflect it up. And now the graph is going to look like this. How about absolute value of the sine of x? Well, I'll take the graph of the sine of x. I know how that looks like. A rough sketch. The graph of sine of x looks like something like this. Oh, didn't pick it up. Not sure why, but when you put an absolute value on it, this is y equal the sine of x. What that does, that eliminates that part of the graph. Actually, let me keep it in. What that does, that will take the negatives so the positive you leave, that will take this negative part and reflect it. Take the negative part and reflect it. So it looks like that. That's how the graphs look like. If you happen to have an absolute values, two of them within one problem, that doesn't happen a lot, but it does happen. You'd say, okay, let's go by, what does f of x equal? F of x equal, let's go by the first. If x is less than 0, if x is negative, then that right there is negative x. And that right there is a negative x minus 2, because that's negative as well. Pick a number and you figure that out. If x is between 0 and 2, well, this is always positive, so I don't need an absolute value there. But this is negative. I would need a negative there. And if x is bigger than 2, which is that piece, this is always positive, I don't need an absolute value, and this is always positive, I don't need an absolute value. So what does this mean? This means x, negative x plus x cancel out, so this is negative 2 if x is less than or equal to 0. Those cancel out. X plus x is 2x minus 2 if x is between 0 and 2, and x minus x cancel out, it's a 2 if x is bigger than 2. So y equal negative 2 if x is less than or equal to 0. Let's say that's negative 1, negative 2, that's included. Two x minus 2 is a line. At 0 you are at negative 2, that's, and if I put a 2 in there, I'll get a 2. And if I am to the right of 2, y always equals 2. And there it is. A circle. A circle is very simple to graph. You go to the center and you move 2 units to the right, 2 units to the left, 2 units up, 2 units down. Connect that with a smooth curve, and there comes your circle. But what if you decided that you wanted to solve this equation? What if you wanted, say, to solve this for y? Move the x over, then you will get y equal 4, y squared equal 4 minus x squared. And when you square root both sides, you will get y equal plus or minus radical x. Well, let me elaborate really quick. If I take this positive, y equal positive the square root of 4 minus x squared, y is always positive. That's referring to the top portion of this graph. That's how the graph looks like. And if I look at y equal negative the square root of 4 minus x squared, again, this is a radical, this is always positive. The opposite of a positive is negative. Y is always negative. That's referring to the bottom half of the graph. And if I decided to take this problem and solve this instead of for y, solve it for x. And if I square root both sides, I'll get x to equal plus or minus the square root of 4 minus y squared. Well, x equal positive the square root of 4 minus y squared. That indicates that this is always positive. X is always positive. That's the right half of this graph. So it's the right half of a circle. And if I was to say x equal negative the square root of 4 minus y squared, and even index radical is always positive, a negative in front indicates that x is always negative. And that would be that piece. Something to really think about as we move on.